how can the universe come from nothing? How does matter gets created from nothing? It's a beautiful thing that you've written there, if you can elaborate.
The idea is simply that the distinction between nothing and something is a little old-fashioned, the common distinction, because we know that particles can pop in and out of existence, virtual particles, due to laws of quantum mechanics and relativity. All around us in empty space, particles, virtual particles, and their antiparticles are popping in and out of existence, and then existing for a very short time and then disappearing. But if particles were to pop up empty space and have zero total energy, say they were in a gravitational field and the negative gravitational energy equaled the positive energy of their mass, so that they didn't violate energy conservation, those particles that popped into existence could exist, could be real and be measured, and so empty space could literally burp particles into existence. Similarly, if space and time are described by quantum mechanics, if we have a quantum theory of gravity, whether it's string theory or something else, then space and time are quantum mechanical variables, and space-times can pop in and out of existence. And so a whole universes can pop into existence. And if normally they will disappear very quickly because of the laws of quantum mechanics. But again, if they have zero total energy, a universe could pop into existence and exist for as long as we've been around, 14 billion years or so. And so you can pop whole universes into existence. And if the universe has zero total energy, you may say, where's all the matter come from? But again, gravity can have negative energy. So you can account for you can balance the positive rest energy of particles with the negative attraction of gravity. And you can still have a universe which has zero total energy, even if it's full of matter. And so it doesn't violate any laws of physics to create a universe full of matter from literally nothing. And I find that absolutely fascinating. There's no proof that it happens, but the laws of physics certainly will allow it to happen in principle.
You also talked about the closed universe, the open, and the other one I think was the flat.
Yeah, and so, that was kind of formalism which was really relevant before we discovered that empty space has energy. But the universe can exist in one of three geometries: open, closed, or flat. These are four-dimensional geometries, and therefore not easy to picture. But it turns out that while we really can't calculate very well in a flat or open universe, we can calculate that in a closed universe must have zero total energy. So if a closed universe pops into existence, it could survive. And if it underwent some processes like we think happened in the early universe, something called inflation, it could expand and survive right until the present day. And in fact, the point is that if you ask what would be the characteristics of a universe that popped into existence from nothing, given the known laws of physics, what would be the characteristics of that universe that you'd measure today? It'd be precisely the characteristics of the universe we see around us. And that's, again, not proof, but it suggests it's possible.
Right. So ours is a closed universe, or
well, it looks flat on large scales, but the universe can be much larger than we can see. Just like in Kansas, the Earth looks flat, but on larger scales, we know the Earth is round. And so maybe on the scale of our horizon, the visible universe that we can see, the universe appears to be very, very flat. But on much larger scales, it could eventually curve around and have closed geometry. That's what I think is the likeliest bet.
You also talked about that all of the universe's matter can be condensed into 30% in total. And so the rest is the empty space.
Early history of the universe, everything we see, all of the matter and energy that's now in our universe was condensed in a region smaller than the size of an atom. It's amazing to think about, but that appears to be the case. It's fascinating and very difficult to picture.